Hello everyone. For this first video in the Fortran series, I thought we'd do a nice simple program. I'm not going to do traditional hello world, seems a bit boring and lame. IO also isn't Fortran strength, it's calculation, so I figured we would do something maths related. So what is like the simplest maths program we could write that even a child would understand? How about we write a quadratic root solver? So we're going to take a quadratic equation and calculate the roots for it. So that's what we're going to do. Nice simple program. I'm sure you all remember the quadratic formula, probably burned into your minds, is minus b plus or minus the square root of b squared minus 4ac all over 2a. Oops. So I don't know how good the contrast is for comments here. But it's basically going to be minus b plus or minus the square root of b squared minus 4ac, and this is all going to be over 2a. That's including that. So that's the formula we're going to implement to solve for the roots of a quadratic. Just as a graphical representation, quadratics like this, the roots are where it crosses the x-axis. So obviously if it dips below, we're going to have two roots. If it just kisses the axis there, we're going to have a single root where it touches. And if it's just purely above the x-axis, we're not going to have any roots. So there's kind of three cases we need to solve for there. Pretty easy to calculate. Essentially, I'm sure this has it here. We're going to calculate discriminant. When the discriminant is greater than 0, it has two real roots. When it's less than 0, it has no real roots, they're imaginary. And when it's equal to 0, it means it's touching, we have a single root. So that's what we're going to do. So to start any program off in Fortran, you're going to want to use this basic keyword implicit none. You don't have to. Suggest you do. Let me just quickly show you what happens if you don't. So I equals 1, x equals 1, and then just write I and x out. So this right star, so this first star means standard out. Second star is kind of like a formatting thing. If I remember correctly, it's basically this one means list directed IO. What does that mean? Don't really have to worry about it, but you're just kind of leaving the formatting up to the program. So we're just going to write I, comma I, so that's how we kind of write the value of I and that, and let's just write our x. So if we compile this, cool, Fortran examples, is it G Fortran, we're going to compile, I'm going to call this Q root, and it's called quadratic root.f90. So this will compile, and now we can just run basically qroot to run the program. You see how I is 1, the integer, and x is 1, the float. That's because in Fortran, I, J, K, I think are the ones, they're implicitly integers, just because they're commonly used as like loop counters, and anything else is floating point. I think there might be some as well that are implicitly strings, but doesn't matter because basically never use it. So if I try and compile this program now, it should fail. Yeah, so we get some compiler errors basically saying we have no implicit type for I and x. So if we wanted to do this, we would have to do real is x is a real, and if we wanted a int, I think it's integer. And I think we can also do an integer like 4 here. Let's compile that. Cool, there we go. And if we want them both to be real, we can also do that. Cool. Now, okay, so this real 8, what does this mean? Think of this as kind of like the floating point precision. So if I do a let's actually do let's do A, B, C here, A, B, and let's do a C. So if we make this real 4, 8, 16, we do our same trick as well. A equals 1, B equals 1. So we're setting them all to 1, but they're all real numbers of basically floating point, just with different precisions. Then we just write them out. Let's compile that and run it. You see we basically get very different, precisions here. So 8 is typically the one I default to unless, I have a very specific reason. I did actually look at the Fortran 90 documentation. So if you look at floating point numbers, so we did actually look at this documentation, this real DP kind stuff. It feels new to me. It might not be. I might have just always used 8. I did a little bit of reading, apparently like different compilers. I think it's the compiler that handles things differently, or it might actually be like at runtime itself that 8 gets interpreted differently, but they basically suggest you do this now. So if I do this, basically we have a parameter called DP, which is of kind this. I'm assuming it's some kind of magic inbuilt thing to Fortran, and it's an integer. And then basically real, now you can use it here. So this real takes an integer. Let's call this DP. No, I can't do that. Let's call it D. So we make D equal 1. And then we write D. Let's see what this looks like. So yeah, this is kind of new to me. Let's compile it. Yeah, cool. So it looks like it's 8 anyway. I was going to say like real 8 is what I've defaulted to. Just for the hell of it, I'm going to keep using real 8. But, obviously there are times when you want different levels of precision. So let's start by writing our program. We're just going to print standard out. The first thing, this program solves for the roots of a quadratic equation in the form ax squared plus bx plus c. And then let's do another line and say, please tell me the values of a, b, and c. And now to read those in, we basically do a read. Star is standard in, star is list directed IO again. Read format, we can not worry about it. And then to store those, we just do A, B, and C. So we're gonna, whatever we read in from standard in, we're gonna store in those. So we need to define these. We're gonna do real 8. Real 8. We can define multiple variables in the same line like this. So they're all real 8s. Cool, so that's how we read that in. What's next? We want to, what do we want to do? So we're going to find the roots, so let's just write this program all at once because it's pretty straightforward. So we're going to have the roots, I'm going to call them x1 and x2. And I'm also going to store the discriminant just because it makes some calculation a little bit easier. I could line these all on one line, but I actually like to, even though I do group some things on one line, I like to break them up by use case. So input, you might even put something like here, user input, user output, and this might be, intermediate variable. Just makes managing these declarations a little bit easier for me. So that's typically how I like to spread it out. You do your baby. So the first thing we need to do is calculate the discriminant, which is going to be pretty easily. So we do that. Discrim is going to equal, and that is b squared. So squared, we just do star star 2 minus 4 times a times c. So that's our discriminant. And then we basically have 3 cases for this. We have if the discriminant is greater than 0, equal to 0, or less than 0. So if we go back to this tab, when roots, when discriminant is greater than 0, we have 2 real roots. When it's equal to 0, we have a single real root, and when it is less than 0, we have imaginary roots. So if statements, if discrim greater than 0, then, and if is how you end the if statement, so it's pre-filled that for me. So x1 is our first root. It is going to equal to minus b minus the square root, which is an inbuilt Fortran command of the discriminant. We're going to divide all that by 2a. and x2 is going to be the same, except this is going to be a plus. And then let's just write that out, right? The roots of the given quadratic are so x1, x2, cool. Then we can do else if discriminant is equal to 0, double equals, then we're going to say x1, it's just a single root, is equal to minus b divided by 2 times a. I'm going to put some brackets around here just in case. Cool, and then oops. I'm going to do the singular root is x1, and then we kind of have this else, which is the only other case, which is whoops, less than 0. We're just going to write, we're not going to do anything with complex numbers yet. We're just going to write the roots of the roots are imaginary. Cool. And that's pretty much our program. Very simple, like kind of thing you'd plug into a calculator in primary school. Let's compile this, see if it compiles. It does. Let's run it. I wonder if this site gives me some examples. What is this quadratic? X squared minus 7x plus 10. So 1 minus 7, 10. 1 minus 7. Just enter our input like this. That reads them in. The roots of the given quadratic are 2 and 5. How does that check? 2 and 5. Cool. Let's try another one. Q root 1, 2 minus 3. What's that look like? Minus 3 and 1. What about 1, 1, 1? I think 1, 1, 1 is actually imaginary. 1, 1, 1. Yep. Do we have a singular root? I think it might be 1, 2, 1. 1, 2, 1. Yes, there we go. At minus 1. So very simple program, very easy to write. Let's step through the code again. So we've got implicit none. We're declaring our variables. We've covered writing and reading. Some simple math calculations, some if blocks. Yeah, very, very simple program. Like there's no loops, there's no arrays, there's no nested anything. You know, you can't really get much easier than this without being boring and just printing hello world. So hopefully you've enjoyed this. Examples are only going to get more interesting and I guess kind of more real worldy from here. I'll kind of progressively build up complexity in the algorithms we write, the problems we solve. You know, we'll do integration, like numerical integration. You know, who knows, depending on how long I go with this, maybe we'll even build a neural network in Fortran, which is about the complexity I got to in writing Fortran about 10 plus years ago. So yeah, hope you enjoyed it. Leave a comment if there's a particular program you would like me to write or if you have any feedback for this. Peace.